me see. I'm trying to get it to work. Stop this music.
No, wait, it's there now, but it wasn't there all day today.
No, yeah, it's not supposed to be there all day today. Let me see. Okay, there we go. Oh, okay, good. Yes, okay, there we go. Now we have a connection. Okay, cool. And it's public. Okay, good. Yeah. What's up, Sensation? How's it going, dude?
It's all horrible.
Yeah, my dad's flying to England right now. My mother's already there. I will probably be going over in the sometime soon future too, because I have to go. Now I got to go for a funeral. My nonno, who finally passed at the age of 98. Congrats to getting to 98, nonno. But yeah, he passed over the weekend. So now I got to go to England. I got to go to Sicily for a funeral in like a month or two. So I will probably come to England first, because that's kind of our home base. So maybe we can arrange for a meetup. That'd be kind of fun, yeah. I get to see the.
Come with you to Sicily.
Yeah, just come with you to Sicily. My family will all ask me, like, this is my bodyguard. Like, I'm kind of an important person right now. I need a bodyguard.
It's been a long time since I've been to Sicily.
Right? Yeah. I mean, me too. Honestly, I haven't been since what was that? 2018? No, 2012. Sorry, I've been to Sicily since 2012. 12 years ago.
99.
99. Well, yeah, I wasn't even. I was a wee lad at that age. Yeah, I probably have pictures. Why do I have to keep logging into my Facebook? Log into my Facebook, please. Thank you. 1 sec. I don't know what does this. Anyways, so yeah, today's Tuesday. Good to see everyone here. We had a lot of questions yesterday. We got some circuit analysis questions. Do you do circuits, Sensation? You do circuits, right?
In the vaguest sense. I mean, I just kind of sit there with a circuit probe and go, "Does this work?" Nope.
Does this work? Yeah, that's like it's your job, right? Sorry. Like one of your main jobs. No, you're good. Isn't one of your jobs like putting together like circuits and stuff, like fixing things at least?
Well, you open the console and they're not exactly complicated. So you just sit there and go, right, what's the problem? And then you just kind of poke around and, you know, how can I put this? You clean the thing out and then you refurbish the solder, and generally speaking, that works 99.9% of the time. So,
do you use a lot of what is it like? What's it called? Contact cleaner? Yeah.
Yeah. I use nail varnish remover.
Oh, nice. That's pretty dope. Okay, that's cheaper than probably circuit board cleaner stuff. Yeah, right.
It's still acetylcholine. Well, not acetylcholine. That's a neurotransmitter. What the fuck am I talking about?
Yeah. Right. Okay. Wow. Whoa. Equity hit 100 stream streak. Wow. Congrats, Equity. That's really cool. Yeah, Bob Ross is Equity. He's made it to 100 of these live streams in a row. Wow. That's awesome, Equity. You know what? I'm going to give you a gift, Equity. You want a gift? I'm going to give you a gift. Here. I'm going to give you, because we also need the server boosts. I actually have to give out 2 things at Discord Nitro, but because you got 100 stream streak, I think you deserve it just automatically. So we're going to give you a free month of Discord Nitro.
That's dope.
Nice. Yeah. Oh, there's Sensation. Where's Sensation? There you are. What's he got? Oh, nail polish remover.
Acetone.
Nice, acetone. Yeah, that's basically what it is. Yeah, exactly.
Ingredients: acetone, aqua. Literally,
it's just acetone and water.
Yeah.
How do I find Equity? When's the last time you've chatted me, Equity? I'm looking for you. I don't think you have in a bit. Jeff, Obi-Wan Pez. When's the last time I've actually chatted with you?
I am so incredibly ginger.
Yes, you do have the ginger beard going on. Oh, there we go. Okay, here we go. Let's get him. Wait, where's Nitro? Why is it just basic Nitro and Nitro? Why can't? Oh, there you go, Nitro. Oh, they made it all tricky now. 1 sec. Okay, here. Yeah, we're gonna do. Okay, 1 month of Discord Nitro. There you go, Equity. Congrats. Go forward. Go. Come on. Yes, there we go. You win. Very welcome. Okay, awesome. Yes. Yeah, welcome everyone back to Office Hours. We're going to go through some homework questions today. Also, we're going to do our $50 Robux giveaway. So if you asked a question last week, you got entered into this giveaway. It was who was it? Fembox donated their prize from the SAT competition, and he wanted to give it out as Robux to one of the other students. So we're gonna do that as well. To kick things off, let's see. Maybe we can do some circuit questions. Actually, where was? Help screenshots. There we go. Okay. Ooh, we got a couple. Ace has a good. Oh, you have a 2D projectile question. I love that. And then Mika has a question as well. So let's see. Is Mika around? Mika, you want to do your question? Mika's asking about the unit circle, the pi circle. Ace has a physics question. Here, let's just see here. I'll wait for Mika to come back, and then we'll do Ace's question, and then we'll do the Robux giveaway, and then I'll do Sensation. I can do the circuit things for Taco Cat. You probably remember everything, Sensation. When we go through like circuits, you'll remember it. It's not too hard. It's like circuit goes here.
Yeah.
Just spray
That
contact
sounds
cleaner
really
on
loud.
stuff. No, you're good. You sound great. Your voice is great.
So there's ever so slight feedback. My own
Oh.
voice grinds me.
Oh, okay. Is it now? Do you hear it now? Sometimes if I have my mic too close to my headphones, it picks up the ear bleed from my headphones. It'll pick you up. Even though these are
And I've
closed
got-
back. These are closed back headphones, but it still like picks up the bleed. And do we have the same headphones? Want to do this? Want to play the game? All right, let's start the stream. All right, welcome to Office Hours. My name is Dr. Gold's Action Education. The stream helps you out with math, homework, science homework,
That's dope.
all sorts of fun stuff. Today, first question we got on the bat is from Ace. Looks like we're doing some physics. I love this. Yeah, physics. You know, it's been a while since I've had a lot of physics questions to answer, so I'm actually really happy that you guys are asking physics questions. This is what my PhD is in. Anyways, okay. Golfers trying to improve the range of her shot. Okay, thanks for the follow, man. What is that? Celebrated. Oh, nice, dude. All right, cool. To do so, she drives a golf ball from the top of a steep cliff above the ground where the ball will land. If the ball has an initial velocity of this, and is launched at an angle of this above the horizontal, determine the ball's time of flight, its range, and its final velocity just before it hits the ground. Figure 8 shows the motion of the golf ball. For the solution, we will combine the horizontal and vertical given statements. I guess these are the statements they're telling us. So, delta y, oh, interesting, is negative 30. Oh, this is very interesting. So, they're calling, I don't necessarily agree with doing this, but whatever. We'll play ball. They're calling this y equals 0. Which I think is weird. I would call this y equals 0 and just say the initial height is up at 30. But yeah, y equals 0 is right here. And then I guess we're also going to call x is equal to 0 right here as well. Just to kind of like get our bearings correct. Okay. We'll call this x equals 0. Okay. First thing you want to figure out is the ball's time of flight. Okay. So when they're asking for the time of flight, right? They're asking for how long is it going to take, guys, for this ball here? Let's make it a white golf ball, right? Oh no, I can't really see that well. Let's make it an orange golf ball. Okay, whatever. That looks pretty cool. Okay, and that is too translucent. Where is circle? There we go. Okay. So they're asking how long is this ball going to be in the air when it's launched up like this and goes like this. Woo! And then hits the ground. The way to figure that out is to, again, we're going to use our kinematics equations, but we're going to use them now in 2 dimensions. So before this, in your classes, you were doing 1-dimensional kinematics. So you're using the, where's it? Kinematics equations. One sec. Kinematics equations. Where are these? Are the ones I like these. The Big Five. Is that what your teacher calls them? The Big Five? What's
I
up?
really hope not.
Yeah, the Big Five. Is that like was that the name for like the Maoist revolution or something? The Big Five.
Not
You're not
off the top
talking
of my head.
about
Off,
sensation?
off the top of my head, there was the big four. That was Metallica, Slayer. Yeah, the big four, Thrash. That's the only big number I know.
Wait, isn't there also like the Fearsome Four? Who's like the Fearsome Four? Was that a thing? Fearsome Four.
I would say Tongue.
Never mind.
American football.
American football? No, that doesn't help me out. Okay, it was something. Anyways, Furious Four maybe. Okay, so we have a couple bits of information here, right? We got a velocity initial, right? We have some distances, and we're trying to figure out time. So I need something that has time in it. So I don't really want to use this one, right? This one doesn't even have time in it, so I'm not gonna use that. What's up, Ishan? We could use this one, but I'd need to know what the final velocity of this thing is at the bottom, and I don't really know that. I mean, so careful, because sometimes students will think that the final velocity is 0 because this thing hits the ground, you know? But it turns out, in physics, when we talk about the final velocity when this thing hits the ground, it's like right before it hits the ground. So it's not going to be 0. It's like right before it turns to be 0. So, but we actually don't know the final velocity, so we can't really use this one either. Which means you can't use this one. Can't use this one. Only leaves this one. Cool. All right. So, you may notice that this says delta x, right? But our ball travels in 2 different directions, right? It travels in the x direction, right? When it's doing this, it's going like this. And it also travels in the y direction, right? It comes up a little bit, and then it comes right back down. So we have to write out our kinematics equations in both directions. That's actually what we have to do here. So the trick for this, I like to do this. I like to put a column like this is x, this is y. And then we're going to write down some information that we know, okay? So in the x direction, right, we don't really know. Let's see. X initial, we know is equal to 0. We don't know x final, right? That's unknown. We don't know the time. The velocity initial we do know, and that's going to be equal to the velocity initial in the x direction, which this is what we have to go again to like kind of like how triangles work. So when they gave us the initial velocity, they said it was 25 meters per second at an angle of 50 degrees, okay? So that means this is 25. But that velocity is in both directions. It's in the x direction and the y direction. So what we have to do is we have to end up splitting this, Ace. How do I split this, Ace? What is the velocity in the x direction going to be versus the velocity in the y direction? I see 25 sine 50. Yeah, that's one of them. Which one is that? Which one is 25 sine 50? Vy, good. Yep, exactly. Yeah, so again, if this is a triangle, this is 50 degrees, then the sine of 50 degrees is equal to the opposite, which is VIY, over the hypotenuse, which is VI. So if you move that over, you get that VIY is going to be equal to 25 sine of 30. And then if one of them is sine, the other one is always cosine. So this is just going to be 25 cosine of 50 degrees is equal to VIX. Okay, cool. So we can put that down here. Let's go do it. So this is going to be 25 cosine of 50 degrees. And by the same parallel, we know that VI here, which is going to be VIY, is going to be equal to 25 sine of 50 degrees. I just used the Pythagorean theorem. Oh, interesting. How could you use the Pythagorean theorem? You can't really use the Pythagorean. I mean, you could get you get this one and then you use the Pythagorean theorem? Oh no. Don't do that. No. Just do this, bro. Trust me. There's a reason you want to do this, Ace, and the reason is sometimes you won't know the angle. So you're going to have to leave this as theta. And it's much better to have sine of theta, cosine of theta, because then you end up manipulating something where you do one divided by the other, and you get tangent of theta. So, yeah. You want to get in the practice of doing this. Don't do the... I know the Pythagorean theorem is safe, but, like, don't do it. Okay, y initial, 0. Y final, we actually do know that. And it's negative 30, because this thing goes down 30. So this is negative 30. I don't know the time. let's talk about acceleration. Acceleration is a cool thing. All right, so we have acceleration in the x direction, acceleration in the y direction. What is the acceleration in the x direction versus the acceleration in the y direction? What do you call inverse of cosine? Arc cosine? Is that what we call it? Arc cosine? You mean like this? Or are you talking about 1 over cosine? 1 over cosine is the reciprocal of cosine. That's equal to secant. Cosine number 1 is arc cosine. Yeah. That's arc cosine. Okay, acceleration. Acceleration in the x direction, that's actually going to be 0. Because, and you'll learn about this late. I don't think you've done Newton's laws yet. But, yeah, the velocity is constant in the x direction. This thing is moving at a constant speed this way until it hits the ground, right? But because of that, because the velocity is constant in the x direction, there is no acceleration, okay? The other reason you're going to learn this is that in order for there to be an acceleration, there has to be a force. So what we learn later is that the force on an object is equal to the mass times the acceleration. And so if the acceleration, if there's no forces on the object in this direction, like nothing's pushing on it to the left or right, then there can't be any acceleration. However, in the y direction, there is an acceleration. Next unit is forces. Yeah, cool. Yeah. In the y direction, there is. Yeah. And that's because anything in the air, good, has an acceleration due to gravity. And that comes from the force of gravity. So the force here is equal to mg is what we're going to learn. And so the force of gravity causes every object in the air to accelerate downwards, which means the velocity is always trying to go negative. It's always trying to go towards the ground. And that's negative 9.8. I'm going to forgo the units for now just because I'm lazy. We'll write them off at the end. Okay, cool. All right, so we know some information here. So right off the bat, right, I have everything I need to use for this equation right here, right? Instead of saying delta x, I'm going to say delta y. But I have my change in y. That's delta x or delta y. So that's negative 30 is equal to v initial, which is 0, plus 1/2 times negative 9.8 times t squared. Okay? So now, we have this information for y. If we look for x, right, if we try to do for x, I would say, okay, well, I don't know delta x, right? I know x final minus 0, which is just x final, is equal to v initial. So that's 25. Oh, and I fucked this up. Sorry, my bad. Thanks, Ace. There is an issue here. You guys gotta catch me here. Because this thing does have an initial velocity in the y direction. I forgot about this. This is vi. The initial velocity in the y direction is actually this. This is 25 sine of 50 degrees times t. Here is 25 cosine of 50 degrees times t. But then this is the one that has no acceleration. So all these terms just go to 0. Goodbye. All right. Cool. So now we're in a little bit of a dilemma because I have two equations, right? But I have a couple unknowns, right? I don't know what the time is here. And I want to solve for this. The xf, x final, that's going to tell me the range, right? That's going to tell me how far this ball moves in the x direction. That's what they call the range. And in order to figure that out, I need the time. I need the time that it's in the air. The cool thing about kinematics is that, do you have to write it like that, or can you just solve for 25 sine 50? You could. I keep everything as sines and cosines for now because sometimes they cancel out. You don't want to jump straight to decimals until you absolutely have to, okay? The interesting thing about kinematics is that when you write out your equations in one direction and your equations in the other direction, this time variable here is the same time because that t describes where the ball is in terms of x and in terms of y at the same time t, okay? So when I say like whatever, like t equals like 5 or something to get x, I would also plug in the same time here to figure out where it is in the y direction. That's how I get the position of something. I'm trying to find out what the position, what the time is for the position in the y direction to be equal to 0. I want to know when the y direction is 0. That'll get me a time. And when the y is 0, that's also the time I want to figure out how far in x it's traveled. That's going to be its range. So we're going to use this equation to solve for t, which is, if you'll notice here, do you see how I have a t and then I have a t squared? Anytime this happens, anytime you have t and t squared, that is a quadratic.
No.
I know, which is unfortunate because they're not the easiest thing to solve. What's up, 12th decade? So in order to solve for quadratics, you can't just like move stuff to the side and divide by t. It doesn't work. You have to use the quadratic formula. I know, it's a pain. The other way to do this is to graph it. Yes, good. You can make one side 0. So yeah, we can do that. So here, let's do that. So I have negative 4.9 t squared. I'm just combining this. And then I need 25 sine of 50. Where is my calculator? There you are. Okay, so this is where you can make things decimals, by the way. 25 sine of 50. So that's 19.15. T plus 30 is equal to 0. Yes. Okay, so one way to do this, guys, yes, would be to use the quadratic formula. So you know that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Where this is a, this is b, and then this is c. Okay, and actually it's just the whole thing. It's the negative as well. Yeah, this sucks. I don't really want to do this.
No.
The way to, because it's plugging in a bunch of numbers and your calculator, blah, 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 blah. There's an easier way to do it, and it's with graphing. And so I'm going to show you how to graph it on a TI-84. Ace, is this the type of calculator you use in your class? Do you use a TI-84? Or maybe it's a colored one or something. Or it could be a TI-83 too. Those work. Not allowed. Oh, okay. You're not allowed any calculators? I'm pretty sure you're allowed a calculator on the physics exam. On AP physics, at least. Okay. Well, I'll show you how to draw it to solve it with graphing. So what you do is you put in this equation. So I'm going to put negative 4.9. It's the same thing as Desmos too, actually, by the way. Negative 4.9 squared, right? And then we're going to say plus 19.15x. So I'm replacing all the t's with x's. And I'm going to do plus 30. And then we're going to graph it. And it's going to look weird. But there we go. Here, we can zoom out a little bit. And there we go. So that's the path of our thing. Cool. Let's see. I can probably, let's make this graph a little better. So we're a little bit more than 5. And we're going up to a height of 50. Okay, so let's do this. Let's make the x min. I'm going to change the window. Changing the window is like changing the zoom level. I'm going to make that, let's make that like 7. The minimum. And then the minimum, yeah, that's fine. I need that calc, Lamau. Yeah. I mean, they have apps for your phone. You can actually get this app on your phone. But here you go. This is what the graph looks like. So there you go. That's the motion of it. Do you see how that also kind of looks like, right? What this looks like? You know? Oh wait, one second. Wait, not. Sorry. Let me do it again. You see how that kind of looks like what this does? Looks like it looks like the same path. They banned phones in class, yeah, because you all just use ChatGPT, dude. Okay, cool. All right. So what we're gonna do next, guys, is we want to figure out when this thing hits the ground, right? And so that's when this graph is equal to 0, right? Because that's what we're solving for. We're solving for when does this function equal 0. So if I want to figure that out, you can do a thing here called you can go to what's called like second calc. You can type in 0, and then you just got to tell it to the left and to the right where you think the 0 is. So I think the 0 starts here and goes as far as, I don't know, like over here. It'll guess, and there it gets us our 0 at 5.11. Okay, cool. So that tells me what t is. So I say t is equal to 5.11. Okay. Notice how there's actually technically another solution in negative land, but that doesn't make sense. Oh, what's up, Grim?
What's up?
I'm doing physics, dude. Did you get out of bed today?
Oh.
Did you get out of the house? Did you get out of the house today?
I'm going out the house right now. Like, I'm gonna go with one of my homeboys.
Okay, homeboys. All right. I hope you're gonna go do some cool homeboy stuff.
Yeah.
Okay.
Very cool homeboy stuff.
Are you going back to school yet? Damn it.
No, not yet. Not yet.
All right. You tell me when you're going back to school.
Okay. Hablamos después.
Hablamos. What is it? Mañana.
¿Hablamos mañana? Okay.
Hablamos mañana cuando tú vas a la escuela.
Cuando voy a la escuela
para
mañana no voy
finir
a la
tu
escuela,
diploma.
que hablas de... No voy a hacer como tarde en octubre.
Dude, October? October is when it starts? Today's already October.
Like late October.
Oh, late October your school starts. Okay, good.
Yeah.
All right. Well, be a good kid till then. But always good to hear from you, Grim. I'm glad.
You just had to check in, you know.
Yeah, I appreciate you checking in. Always check in, please. Like I always like to see what the students are doing. But let me finish this kid's question, and then maybe you can message me when you're back with homeboy or something. Okay.
Bet.
All right, cool. All right. So this is the T here, Ace, right? Ace, this is the amount of time it takes for this thing to be in the air. We can then use that same T to plug in here to figure out what the range is, how far it goes. Okay. Yeah, you just D equals VT. That's literally what this is. Do you see how this is D is equal to V times T? It's the same thing. D equals VT is a simplification of this equation. You're just setting the acceleration equal to 0. Yeah. So now you just go to your calculator and you type in 25 cosine of 50. And then we need to multiply that by that 5.11. And that gets our range, which is 82 meters. Okay, so 82 meters of range. Nice, good job. And then the last part they want is the final velocity right before it hits the ground. Ooh. This is kind of tricky. Do you know how to do this one, Ace? Do you know how to do the final velocity right before it hits the ground? It's actually kind of cool. You think so? How do you think you do it? VFX equals VFIX. Good. Yeah. Yeah. Good. Yeah. Right. So what he's saying is that, yeah, so V final in the X direction was the same as V final in the initial direction. So that's 16.07. Right? Yeah. And then we got to find VFY. Right. Yeah. So VFX is the same as VIX because there's no acceleration in the X direction, right? No acceleration.
No.
That means the velocity in the X direction does not change. In the Y direction, it does, because there is acceleration, because there's gravity. Gravity's changing it. That's pulling that thing down. So we can use, yeah, I made all the, there you go. We're going to use this equation right here. So V final is equal to V initial plus acceleration in the time. So that's going to be equal to our V initial, which is 25 sine of 50 degrees, minus A, 9.8, or plus A, but A isn't negative, negative 9.8, times the T, which is the 5.11. Right. So we have 25 sine of 50, good, minus 9.8 times 5.11. Good. So that gets us negative 30.93. Yes, and then we do have to do a Pythagorean theorem. You are right, Ace. Yeah, because now if I draw my velocity as components here, so VFX is pointing here, and that's 16.07. So that's VFX. And then VFY is pointing down at negative 30. So that's here. So this is VFY, which equals to negative 30.93. And so together, they make a new triangle. Yeah, look at this triangle. Makes a right triangle, and then this is what you're solving for. Yes, you're solving for this. So to do that, we can do the Pythagorean theorem, right? Which just says we take one of the sides, we square it, we add it to the other side squared, we add it to this side squared, and then we square root it. Well, I got to multiply this by -1. Oopsies. I got 26. All right, that doesn't sound right. One sec. I think it's because of this negative thing squaring. One sec. Yeah, oh, man, this is so dumb. You're supposed to square the whole thing. One sec. Times -1. Plus. Well, actually, I want this. I'm getting fancy with my calculator because I just don't want to type numbers in. Okay, there we go. Plus that. Okay, now I square root this. And yeah, you get around 35 meters per second. Yes, good. Oh, he says, why by -1? Yeah, so the issue here was when we got our velocity here on the calculator. See how I got this -30.92, whatever, squared? Or the -30. Yeah, I squared it. And what the calculator does when it sees a number like that and I tell it to square it, if you don't put the parentheses, it keeps the negative. So, for instance, there's a difference, right, between this and this. This is -25, and then this is +25. Yeah, stupid calc. No, I mean, it's a user error, you know. You just got to be smart to, like, not make that mistake. And then, yeah, if you wanted the angle, you could figure out using arctangent here. I think they just want the final velocity. Technically, they want the direction then, don't they? Oh, that's gross. Okay, fine. So yeah, if they ask for the velocity, guys, you have to technically put a direction as well, because velocity is speed and direction. DC node equations. Oh my god, dude. Yeah, I remember doing that. I've taught that. I don't know if I remember those. You could try asking a question though, Cosmic. I could try to go over it. DC node, yeah, those are a mess. Okay, cool. So this gets to be 62.5 degrees. So then we say this would be -62.5 degrees because the angle is down. Negative angles go clockwise, positive angles go counterclockwise. Don't ask me why they do that. It's weird. You would think that clockwise is positive, but it's not in math land. Yeah. 62 degrees. Yes, good job, Ace. Very nice. You could say 62 degrees below the horizontal. I would say -62 degrees. I would just say negative. Yeah, down is a subjective thing. You don't want to say just -60. You don't want to say 62 degrees just down. People can be like, down what? Down where? Hey, we're answering today on our stream. You can join the Discord if you want. Submit questions. Thanks, Sensation, for monitoring the YouTube chat. I need another monitor, Sensation. I already have 1, 2, 3, 4, 5. I need a 6th for YouTube. I need to put a 6th monitor up for YouTube now.
Okay.
The problem is, like, bro, I'm literally running out. I'm running out of slots to put video cards at this point. Oh my god, that's a lot. Yeah, it is a lot. Have you seen my system, Ace? You probably haven't, right? Let's look up. Here, I'll show you guys my. What? Why
do you
can't
have 6?
Why is everything logged out? Okay. Everything got signed out? Why did everything get signed out? That's suspicious. That's suspicious. Why did it sign me out of all my things? I don't have to log back into my Gmail. Whatever. Always something. Where would it be? If I say like setup. From gold? No, I didn't do it. No. Many screens. Ooh, maybe here. Yes, here we go. Here, I'll show you my setup. Well, this doesn't even include the teleprompter yet. I have the teleprompter now. But there we go. This is my current setup for screens for streaming. There's also a teleprompter. There's a new teleprompter up here at the top that I use as well. So, a lot of stuff. A lot of heat. A lot of heat gets generated in this closet. Is that a full green screen room? Yeah. There's a full green screen around here too. Yeah. It's pretty cool. Anyways, okay. I got 2 laptops. Okay. Yeah, I used to run stuff off a laptop and then like it just becomes way too much. All right, let's see. Who else we got? 12th Decade's got a good question. Good. Taco Cat's got one. Here, 12th, because you're here. Or actually no, I said I would do the Robux giveaway. Right? Yeah, let me do that. Let me do the Robux giveaway real quick for you guys. Yes, what's up, 12th? Here, let me do this real quick. So, picker wheel. Gonna win some stuff. And then let's see who asked a question last week. 11-year-old laptop. Oh no, dude. That's way too old. Okay. We got 10 people in the Roblox giveaway. So that's going to be Ace, Cosmic, Equity, Ethan, Sean, King, Obama, OK. I don't know who OK is. Smash, and Smog. So these are all the people that asked questions last week during our office hours streams. And so we're going to spin the wheel. See who wins $50 in Roblox stuff. Let's go. Who's going to win today? Who's it going to be? Oh, looks like it's you, Cosmic. Congrats. Congratulations. Yeah. You win. Thanks, lol. Yeah. Yeah, you're good. Yeah, I'll send you the code later today. I have to get, I have it somewhere in my library. Bum, bum, bum. Thanks for asking a question. That's always the best part. Thanks for participating. Yeah. Okay, cool. All right. Here. What were you saying? Are you tired?
I'm an American.
I'm an American? You're definitely not Chinese. Bro, we had one of my good friends in high school. Had pretty like closed eyes. What's the technical term for it? Like double slit eyelids or whatever. What do they call it? I don't know.
Epithelial folds.
There we go. Yeah, or lacked epithelial folds, I guess, right? Is that the thing? They lack epithelial folds?
No, they're doubled.
Oh, they're doubled? Okay, anyway.
So are mine. That's why I squint.
Yeah, exactly. So my one teacher, bless his soul, from Texas, right? He was my AP Chem teacher. Ends up like looking at our friend. His name was Jason at the time, and he'd be like, "Jason, is there something wrong? Like why are you squinting? Did I do something wrong? Like did I do something wrong on the board?" And Jason's like, "No, dog. This is just how my eyes usually are, man." Oh man, I was just like, "Hey, can you explain how the Good Grades channel works in the server?" Yeah. Submit your grades. That's what it is. I mean, yeah, I guess there are kind of some rules to it. I'll show them for you guys. Yes. Okay, awesome. This is a great example of, so there are two, so in our server, you earn points for doing well in your classes in the real world. And there are 2 ways you can do that. So once a month, you can post a test you took and what your grade was. So here's an example. It says major assessment, A-. Great. That's awesome. Good job. And mathematics, yeah, as long as I can see like what the class is and like what you got and the date, then awesome. That gets you the level 1 score. And then for level 2, you just need to show me what all your grades are in all your classes. like a summary. So some students have this right. They'll do this like they'll show, oh, here's what I have in band, here's what I have in biology, here's what I have in math, and you can do that also once a month. I mean, ideally, I want like a report card at the end of the year, but I understand during the year you don't have really regular progress checkups, so just a summary of your grades is fine. Yo, what's up, Obi? Thanks for the raid, dude.
Nice.
Yeah, it doesn't have to be a report card. You just got to show me that you did well on like a test or something. Yeah, some sort of grade. Yeah. Nice. Okay. Cool. All right. Let's do our next question. Finally, a 10-minute break from this 4-hour exam. Uh-oh. What 4-hour exam are you taking, Laz? What's going on, dog? Four hours, man. That's a lot. Okay, cool. All right, let's put that away. Okay, cool. All right, 12th decade. Simplify and write any restrictions. Okay. Anytime they give you something like this, what's up? Celtare Biaxido Moto. That's an awesome name. You want to explain it? I'm curious for everyone who has these cool names. I want to know what their cool names come from. If you're a friend of Obi, you're a friend of ours, though. Obi's a great guy. A couple of you have gone to get some help with him with Diffie Q. So if you ever have questions in math and I'm not here, or I'm not streaming, please go say hi to Obi. He's got a great stream that he also does some awesome stuff helping out with math, and he knows more math than I do. So if you get up to like the higher level college math classes you need help with, he's your guy. Someone was asking about like topological like whatever some other time. I said go to I guess Eric. Eric knows about this stuff. Rebioxado is a lowered car. Okay, cool. Celta is the car. Oh, Celta, and then moto means style. I'm assuming this is like Spanish, right? Is it Spanish? Or maybe it's maybe it's Portuguese. You think it's Portuguese? Is it Portuguese? Portuguese, yeah. You know how I kind of knew that? Because Portuguese to me is this blend between Spanish and Italian, which I speak Spanish and I speak Italian, but then I don't speak Portuguese. And I would get really confused if I learned Portuguese because the words borrow from both. Yeah. It are a funny name. Yeah, it's a funny name. We'll look. I want to look up this lowered car. In the U.S., we call this a car being slammed, or like, what do they call it? Like flush. What do they call it in the UK? This someone's gonna hate me for this, but yeah. This. One sec. Yeah, it's called like stance, is what it's called. Yeah. This right? This is like if a car is like slammed is what they call it. And I guess they just drop the suspension like crazy, and then it's called camber when the wheels bend out like that. Is there a name for this in the UK? He's like you're a fucking idiot.
Illegal is probably the technical term over here.
Illegal. Oh, okay. Okay, here we go. Yeah, this is where his username comes from. And then 12th, we'll do your question. I'm just curious about this. Look at that. Yeah, okay. It is called low. It's different than low riding. Low riding is different. Low riders are different. Yeah, this is called like stanced. But yeah, they do this thing where they make the wheels look like they're going up into the wheel well and they drop the suspension. And I think usually they do this by what's called, they actually have to roll the metal inside here. Like the wheel well would not allow the wheel to go this high, so they take like a baseball bat and they roll it. Yeah. Yeah. He says they're a really bad car, you know. Okay. Oh, so this is the joke. So you're taking a really bad car and you're making it like pop, or like, yeah. You're putting lipstick on a pig. That's cool. Okay. Yeah, lowriders are different. That's an LA thing. I guess they kind of look the same, but there's more art. Like they do this. They do this gorgeous like art on it. You're right that the wheels are also lowered, I guess. But they're a lot more artistic. They're pretty tasteful. And then sometimes they have hydraulics is what they do. So these cars will like bounce up and down. In Brazil, we have some memes with cars. That's cool. Memes with cars. We like memes. Okay, what's up, Obama? How's it going, bro? Cooking on physics? Fuck yeah, dude.
Nice.
I'm not a stance guy, more of a horsepower modic guy. Yeah, cosmic. Yeah, yeah. It's a different point visual and like actual performance. My school doesn't let us take history and physics, so that's why I'm taking it now. Yeah, nice, Obama, dude. I'm glad to hear you're doing well, Obama. So there's Obama in the chat. Yeah, nice. Good job. Oh, tomorrow's test. Yes, good luck, dude. Good luck to you. Celta Rebiado Moto. Sensation, they're asking how many vapes do you have?
1.
He only has 1. Yeah. Go to office. You got it, bro. Go to office hours. Yes. Dub, dude. Yeah. Good recommendation there. Yes. Okay, cool. Here, let's do whose question was this again? 12th decade. Okay. Simplify, right any restrictions. Anytime you see stuff like this, these are called trinomials. Tri means 3, like tricycle. Nomials means like terms. They're like 3 terms. See how you have like an x squared term? You have an x to the first term. Technically, this is another x term. It's x to the 0. Anything to the 0 power is just 1. So that's why we call it trinomials. Time to factor for the 10,000th time. Yes. Oh, I helped you when you were a freshman? Yeah, I did, Obama. Yeah. Yeah, Obama. I've almost helped you for 4 years in this server. That's super cool. I think you will be the first student, Obama, to start high school in my server and finish high school in my server. I think that'd be really cool. We'll have to get you another special role. Like, I don't know, high school speedrunner. Obama's been here for a full term. Damn, yeah. What's up, Pensender?
Oh, yeah.
Good to see you, dude. I appreciate the pictures of your flowers. The ladies, as they call them. I joined this in grade 9. I'm old, bro. Dude, bro, I'm old. Dude, yeah, and actually Sensation, like, takes the cake on the oldness. Yeah, you're not allowed to say you're old.
I'm going gray and everything.
Yeah, I already, yeah, I have to dye my beard, otherwise my beard goes gray. I don't like the gray beard. I'm not a fan of it. Yeah.
I think I'm going gray anyway. I'm not actually sure, to be honest.
Yeah. It happens. I have a lot of stress in my life, so I go gray early. Gramps. I am Gramps. Yeah. Okay, yeah, so let's factor. What was that, Sensation?
It's just like, what you say, Sonny?
What you say, Sonny? Get off my lawn. I love that.
Yeah, that film is just so angry.
Yeah. According to ChatGPT, the correct way to pronounce it is Hey by Shadow. Yeah, that's it. Okay, yeah, the XI is a Sha. Okay, that's what it is. Which is almost like Chinese too, I think. Okay, 12th. How do I factor this? How do I factor this stuff? How do we do? There's some tricks to this. This one's not so bad to factor, right? Anytime there's a 1 in front, I get so happy.
That's dope.
Because all you have to do is figure out what 2 numbers, like, multiply to 12, and then add to -8. So that's what you do. You check, like, okay, what gets me to -8, and then what gets me to 12, right? So, off the top of my head, right, 2 numbers that add up to 12. Yeah, -6 and -2. Excellent. Yeah, exactly right. Look, -2, -6, right? -2 times -6 is positive 12. -2 plus -6 is -8. Awesome. Okay, so now we know, right? This is going to be, what's that? X minus 2, X minus 6. Okay. This one gets scary though, right? Because there's not a 1 in front, right? I have a way of doing it. Some people may not like it. I can never remember the other ways. There's like this method. I don't like this because it looks like an X. The way I do it is I take this number and I multiply it by this number, okay? And that's going to give me... Quadratic formula to discriminant is 1. Yeah, okay. All right, yeah, we can do that too, I guess. The way I would do this times this. I get -6. And now I do the same thing. I say, okay, what two numbers multiply to -6, but add up to the middle one, which is -5. And then I'll show you the trick with what I do next. Yeah, 12th decade's got it, yeah. We'll see how we get that. My voice cracked. Okay, so I feel like if I do -6 times 1, right, that's -6, and then -6 plus 1 is -5, okay? Once I have that, this is what I do. I make a Punnett square. I'm a more visual person when it comes to learning this stuff, and maybe you are too, so maybe it'll help you out. But then I just take this, I put it in the top, I take this, I put it in the bottom, and then I take these, I attach an X to each, and I put them on the diagonals. So -6x, -5x. What's up, Don? 13 viewers, what's up? Oh, wow, we got a lot of fun today. Oh, Don, man, I've missed your streams. Do you stream earlier in these days, I think? I think you do. But yeah, shout out to Don. Don's a great guy, awesome. Yeah, we love Don. Awesome source of math help. Great player of, what is it? DayZ. Yeah, DayZ. Great player of DayZ. Are you still playing DayZ? What's up, Femvox? Good to see you, too. And Zach's here, too. Yeah, what's up?
Nice.
Yeah. Oh, I've been streaming a little bit less. Yeah, still doing DayZ. Sweet, man. Awesome. Yeah, we're just doing, what are we doing? A little factorial question here. What's up, Gold? Yeah, happy to see you too, Fembox. Thanks, man. Appreciate you. We were talking about, like, factoring stuff when the first number isn't 1. So the way I usually do it is I do this times this, and then I kind of, like, factor that number, and then I break it out into a Punnett square. They also will do this without doing the Punnett square. They'll do it this way. They'll take this, and they'll say, okay, all we're doing is dividing this -5x into, wait, I messed this up, sorry. I messed this up. I want to take this, put x, put it here, and then I want to take this and put x and put it here. Sorry, this is +1. I messed up. Okay, this is +1. I got excited with all the raiders. Yeah, trying to explain it. Yeah, so what you can do is you get your two numbers, right? -6, +1. You put them on the diagonals with an X, and then keep the original terms on the top left and the bottom right. And then it becomes like a Sudoku puzzle, which I'll show. The other way to do it is to rewrite this -5x as -6x plus 1x. So all we do is we just split this up, right? Because -6x plus 1x is -5x. And then to also write the -2. And then what you do is you try to factor this. So you try to pull something out of these two, which in this case would be pulling out 3x, which would leave you with x -2. And then from here, you can pull out just a 1, right? So we can say just +1. And that also becomes x -2. And now what you have is, right, you have a times b plus c times b, which is the same thing as a plus b, or a plus c, sorry, times b. So in this case, it becomes 3x plus 1 times x -2. I don't necessarily like this because sometimes the negatives mess up here, and you have to know to pull out a -1 to make this one the same as this one. So it's not necessarily always intuitive. The way I do it with the Punnett square here is I just look at any sort of row or column, and I just try to pull out the most stuff I can from that. So right here, the most I can pull out, right, is a 1x. Right, I can pull an x from here. I can pull an x from here. I can't pull a 3 from here. That doesn't work. So I'm just gonna pull out x, and then it becomes kind of like a reverse engineering thing where I'm just trying to figure out what times what gets me the middle thing again. So x times something gets me 3x squared. So that would be 3x. And then I move down to the next thing, right? 3x times something gets me negative 6x. That would be negative 2. Negative 2 times something gets me negative 2. Well, that's just 1. And then you can always check this. Look, x times 1 gets me 1x. And now you're done, because now these are your factors. So you have x minus 2, 3x plus 1, which is the same thing as we got here, right? So we're doing the correct stuff, yeah. All right, so now that I have that factored, right, we have this. What do we have? X minus 2, 3x plus 1. Saltaire sends, watching your live stream will be very good for my test tomorrow. Like the tests are mathematics and English. Yeah. Is English not your first language, Saltaire? Imagine that would be a pain. English is the language of math and the language of science. Although some people really like German, I guess, for science. Yes, Decade. Perfect. Yes. So what you see right away is that we can cancel the x minus 2s. And that just gives us 3x plus 1 over x minus 6. Okay, cool. Nice. All right. So that's just simplifying it. What are the restrictions? You're from Brazil, so you speak Portuguese. Okay, yeah. But you learned English. You can obviously speak English in my chat. So your English is decent for texting, at least. Voice might be a little bit harder, I guess. X does not equal to 2. So actually, here... No. So yeah, here's the thing. X can equal 2. So you're right at this point in view, at this point, 12th decade, it would appear, right, that X cannot equal to 2. Because that would cause the denominator to be equal to 0. And also X could not equal 6 because the denominator would equal to 0. However, the X minus 2 got disappeared. It got removed. I don't know. Yeah, it left the party. Irish goodbye, whatever you want to call it. So that's called a removable discontinuity. So you can say this. You can actually say removable discontinuity at x equals 2. But the only restriction is at x equals 6. That's it. That's the only restriction that still stays. Yeah. You will learn this in calculus, guys. This is a calculus concept. When you start doing limits and things, and they want you to figure out where the asymptotes are, where the discontinuities are. If you can you're right that dividing by 0 is bad. Tends to break things, right? We don't want to divide by 0. But if the thing dividing by 0 can get canceled by something on top, it's removable. Followage. Yeah, does my followage not work? I don't know. More asymptotes after grade 11. I don't know. Stream Elements is probably messing up. You feel that x over x and 1 are different functions? Maybe on a curvilinear space, dude. But they're the same. R.I.P. Anyways, okay, cool. Great job.
Yeah.
There, 12th decade. Yeah, nice, dude. You get a bond coin for that. X minus 2 over x minus 2 certainly grows at the same rate. Yeah, I agree. Now, I mean, where these are different is actually, that's funny. I was working on this with a student the other day. This is not the same, though. Right? This does not equal 1. Turns out it equals plus or minus 1. Depending which way you're coming from. X equals 1 for x not equal to 1. Yeah, but as x not x equal to 0, but as x approaches 0, it goes to 1. So it basically is. You can't plug it in, but for all intents and purposes, like it basically is 1. This graph ends up looking I think it's something like this, right? And where this is like 2, and then this is positive 1, and then this is negative 1. This is an example of something that looks like it should just be equal to 1, but by the limit definition, it isn't, right? If you come from the left, it's negative 1. If you come from the right, it's positive 1. I can explain that later. That's a cool calculus concept. 12th asks, Gold, what's the AMA podcast hour? Good question. So that is a stream that I do on Fridays where we have guests come on to the Twitch, and you guys get to ask some questions. And so a lot of times our guests are people with cool backgrounds. We've had people that have been math professors,
people who have been professional soccer players, people like Penn Center who have also redeemed baby voice and made my voice go in a very high pitch. But yeah, we had a therapist on at one point. We had quantum gravity research. We've had a lot of cool guests during the year. I kind of took a break from it over the summer because I was busy with other things. I am going to restart it this fall. I'm going to start sending out requests for guests. So
yeah, it's in the schedule. But wait for me to make an announcement when I know for sure I have someone on Friday to interview for you guys. They are very fun. And we give out prizes and stuff, and it's cool because AMA means ask me anything. You can ask our guest whatever. I mean, within reason, as long as it's like safe for Twitch. Don't get me banned. But it's a cool way for students to figure out, hey, how did you adults do this whole life thing? Like, what was your path? It happens on Fridays, usually at 6 p.m. Pacific, which it will be 9 p.m. Eastern time. Yeah. That's when it is. Okay. Cool. All right, let me get another question going up. We have some circuits we got to go through. Will it happen this week? Probably not, because it's Tuesday, and I usually need a couple days to confirm a guest. But I will get guests for this fall. We've had a lot of the people actually here in the chat have been guests. So we've had Penn Center be a guest. We've had Zach be a guest. We've had Obi be a guest. Don, you want to be a guest? Don, you want to come on my podcast? And then we can start doing repeats. Penn Center was like my very first one. And we had so much fun during that. We've had a lot of cool guests here. Yeah. What's up, Falcon?
Yeah.
Falcon's our resident tree person. Resident person of the trees. I would, but I feel like I'm too boring. I don't know what to talk about. Oh, no, don't worry about that. You are not too boring, Don. Don, you are an interesting person. Dude, what? If Penn Center says I can show off my plants. I think that would get us kicked off of Twitch, though. You showing your plants. Okay, this is cool. Salah has a question. I might need... Does anybody here speak French? I think this is French, right? Can I identify as an ent? Yeah. All right, thanks, 12, dude. You're very welcome, dude. Thanks for coming by. Oh, yes. Yeah, wait, Penn Center, you speak French. Aren't you from the French-Canadian part of Canada? Oh, I need this. I don't... Well... So, I think I could also use ChatGPT to translate this, right? Exercise 2. Calculate. Yeah, so calculate the sup and infinite of the following sets of R. And, okay, the upper limit and the lower limit. Yeah, so, yeah, there's a name for this also in, yeah. Is this real analysis, Penn Center? I feel like this is real analysis, right? Yeah, this is the supremum. Supremum? Yeah, supremum and infimum. This is real analysis. Okay, I know fuck all of real analysis. So, Penn Center, you want to help me solve this one for someone? Calculate. Okay, the upper lower limit of the, R exists. Did someone say real analysis? Yeah. Yeah, exactly, Zach. This is your specialty, right? You love real analysis. So it says, I'm going to try to do this. So this is A plus, is this BN over N? Get Zach on the phone. Get Zach on the phone. Get him in here right now. For A is greater than 0, B is greater than 0, and then it says I equals this, J equals this. Is this necessary here? Do I need this as well? Okay, good. Good to see you there, Celteria. Good luck on your test tomorrow, man. So N is like contained in the natural numbers, right? That's what we say. So B is contained in the natural numbers, where A is greater than 0, B is greater than 0. I don't know what this Bn over N is. Oh, it's just a separator. Oh, you fancy math people. I would have put a semicolon here. Okay, so they put it like that, separator. Okay, so all right. Okay, so it's A plus Bn, where A is greater than 0, B is greater than 0, and N is a natural number. Or what's the fancy, like that? This is limsup. What is limsup? What does limsup mean? Limb soup. I could go for some soup. I'm kind of hungry. Who wants to feed me limb soup? Limit of the supremum. Stay tuned. This is meeting 8 on Thursday. Are you going to do real analysis? This is also limits. Oh, is this also part of your limits and series class, Zach, that you're doing? Did I shout you out, Zach? Let me shout you out. Yeah, if you want to learn, I need to put your thing on my schedule too. Oh, that's awesome. Yeah. So, Zach is Eat of the 2i Pi is doing a limits and series, infinite series class on Twitch. So if you want to learn math with Zach, that's his Twitch. I need to put your schedule on my bot so I can tell all the kids. But yeah, and that's actually what Zach's whole, I think your dissertation was about, right? How to teach this, like, to people correctly. Yeah, it's cool. It's one of the more complicated things. Okay, but so what's I and J though? What's I? What's J? I know et means and. Yeah, that was part of your master's. Yeah, it was your master's dissertation. Okay. So we have I is equal to x squared over 1 plus x squared, where x is all real numbers. And then J is equal to x squared over 1 plus the absolute value of x. And then here x is also contained in all real numbers. Yeah, I agree. I think it is too, because I see it here and here as well. But then, what is I and J? What's going on here? Oh, I is the name of the set, as is J. Okay, those are two sets. Okay. Oh, they're subsets of R. Okay. Okay. Oh, they're all. Oh, okay. Oh, B, I, and J are all subsets. Oh, I see what you're saying. So does what does supremum and infimum mean then? I don't. Do I want to learn it real quick? Someone want to teach it to me real quick? Let's use ChatGPT. That's tonight. It's the greatest upper bound. Supremum is the value that exceeds all elements in a set. Wait, least upper bound? That sounds like a double negative. Okay, the least upper bound and the greatest lower bound. Oh, okay. Oh, okay. Okay, for the set here, the supremum is 1, even though 1 is not in the set. Okay. I got you. Okay, I think I understand this now. So it's just a fancy term for like what's the min and the max? Is that really what it is? Kind of, yeah. So, Mm-mm-mm-mm-mm-mm. The element doesn't have to be in the set itself. Yeah, well, I mean, what I see here, right, is these are both greater than 0. So is the smallest thing 0? I feel like the smallest thing is 0, right? I feel like infinitum is equal to 0. Like 1 minus 1 on n, if n is a natural number, has a supremum of positive 1. And would it have an infinitum of 0? Does n start at 1 or 0? N is a natural number. So I feel like the infinitum is 0, right? Because at some point, there's slightly greater than 0. Yeah, for set B, it's A plus B, right? Because n is a natural... Is 0 a natural number? Wait, is 0 a natural number? Oh, they don't include 0. 0 is not a natural number. Wait, but that's outside the set. 1 is the first natural number. God. Cosmic says, how cooked am I for a physics test tomorrow? I'm getting the equation sheet, but I haven't done much studying. I've been trying on homeworks. Yeah. For me, man, Cosmic, if you're studying for a physics test, doing the homeworks is studying. Like, you're okay. That's what I would call it. Okay. Oh, we have to do it for all the sets? Not each set individually? Yeah, is the limit is 0. Okay, so we have to do it for all of them, right? Okay. Each set individually. Okay. So, here, isn't the supremum of B equal to infinity? Because A and B could just be as big as I need them to be. And then the infinitum of B would be equal to 0. Okay, I agree with that. Here, the supremum, I believe, would be 1. Right? Oh, A and B are fixed. Oh. I agree. Okay, I see what you're saying. A plus B is infinitum. Okay. For this, like, as X gets really, really big, right? This 1 basically becomes insignificant. Right? So, I see the biggest you can get is infinity over infinity, which is basically just 1. And then if they're small... Oh, it says X is all real numbers. So then the infinitum is just 0. Oh, sorry. Let me make this right. That makes sense to me. Okay, cool. I'm learning real analysis. Wow, see? We learn something every day, dude. Okay, this is weird, though. All right. 1 plus the absolute value of X. X is all real numbers. At infinity, that's just infinity, right? Yeah, right? Well, yeah, yes, because even if this gets down to 0, yeah, 0, right? Because if I make this negative, that's positive, that's positive. Yeah, you're right. Okay, cool. So I'd say the infimum of J is equal to 0. And then the supremum of J is also equal to positive infinity. Wow. Nice. Good question. I win knowledge. Thank you, guys. There is one more, but it's cut off in the screenshot. I can't see it. Yeah, here. Yeah, thank you, Jeff. Well, thank you all of you guys. What? You all get saves, dude. Pen Center, you've only saved my server once, dude. There was nice. There you go. Yes, awesome. Oh, does leaderboard not work? Maybe it doesn't work. But okay, cool, awesome. Thanks, guys, for teaching me that. That was fun. See, this is why I love this community. It's just like, you know, we all have different skills and stuff. You know, I've helped Pen Center out with physics. And yeah, these guys helped me out with real analysis. I never took real analysis. That was my upper limit, or should I say, my supremum of math classes. I stopped at complex analysis. How long's the queue for the questions? I don't think there's really a queue at all right now. You want to post a question? Let me post this for someone. Salah is who I just helped out. So, yeah. You got all right. Equals. If you have a question, equals. Are you part of our Discord? Discord's the easiest way to submit questions, unless you want to type it out. You can type it out if you want to. But there's a Discord where you can post a screenshot of it. Okay. Go for it. I'm gonna give this to Salah. What is Jeff's asking some questions here, dude. Oh yeah, post it in the screenshot section. Thanks, yeah. What's the formula for the Great Circle Bath between two locations on Earth, Dr. Gold? The Great Circle Bath? What the fuck's a circle bath? Like a bubble bath, but with circles? Oh, what's the formula for the Great Circle Path? Oh, okay. So I assume Jeff's always asking these funny questions about like non-Euclidean geometry or something. But I guess we would have something like this. Is this? I'm trying to draw my Earth today. No, she's not earthing. She's not earthing. It's something like this, I guess. Can I do it? There we go. There we go. There we go. No. Yeah. Posted? Cool. I'll go check yours out. Yeah, I think he's talking about like this. It's like if I have like something here and like something here. Is this called like the Great Circle Path? Oh, Great Circle Map. Oh, let me check it out. Oh, this is dope. Is this like the shortest distance? Is that what we call this? Yeah. Oh, very cool. Yeah, this is very interesting. Like, for instance, so if I want to go from, let's say, like, LAX to, what's Heathrow? HTR? HR or something? Oh, LHR, yeah. It's kind of cool. You almost go over the North Pole. So this is, yeah, Los Angeles to London. Just to, you know, technically the supremum does not exist in the real numbers, but it does exist in the extended real numbers. Oh, okay, cool. All right, here, let's have a okay with this question. All right, given the graph, match the correct equation from multiple choices below. Okay. Cool. Oh, I see. It depends on the rules. All right. Is it cotangent, tangent, or something else? Okay. The first thing I notice here, right? I always like to just like plug in points and just try to see what's going on. So I need at x equals 0, I need y to equal 0. So let's just kind of look if this makes sense, right? So if we look at here, for instance, the cotangent of 0, right? 3 times 0. So cotangent, right, is equal, that's 1 over tangent. So instead of opposite, it's equal to adjacent over opposite is what it is. Okay. Adjacent. Oh, so I need the adjacent to be equal to 0. Okay. If the adjacent is equal to 0 on a unit circle, yeah, I believe it is actually undefined, isn't it? Right? Cotangent of 0 is undefined. Yes, because sine of 0 is 0. Yes, I agree. Good point. Yeah. So, yeah, good thing about cotangent. Cotangent is, yeah, technically cosine of theta over sine of theta. Right? So that would be equal to the cosine of 0 over the sine of 0. Uh-huh. Yes, okay, I see. So that doesn't really work. Oh, oopsies. Right, because the tangent of 0 is 0. Right? I know that one. Yeah, can't divide by 0. Use Zach's formula. What's Zach's formula? Just cosine and sine? What's Zach's formula? Okay, so it can't be this one. Right, this doesn't work. Can't be this, okay. Could it be this? We can check. So plugging in 0, that's the cotangent of negative 3 pi over 4. Okay. I don't think it's going to work either. Because that's the cosine of negative 3 pi over 4 over the sine of 3 pi over 4 or negative 3 pi over 4. Which negative 3 pi over 4 is located in this quadrant, right? This is 1 pi over 4. Oh, wait, no. Sorry, it's located in this quadrant. This is 1 pi over 4, 2 pi over 4, 3 pi over 4. So cosine is negative square root of 2 over 2. Sine is square root of 2 over 2. So this ends up equaling negative 1. Which it does not either. Not going to be that one. Okay. So by process of elimination, it has to be this. Does that make sense? Equal? Why it has to be that one? I think it just has to be that one. That's my process of elimination. Okay. I think the proper ways. How's it in the second quadrant? Oh, okay. So yeah, what I did was I plugged in x was equal to 0 here, right? So that was the negative 3 pi over 4. Is it? No, I think it's the second quadrant. Oh, sorry, it's backwards. Yes, no, you're right, dude. It's not going this way, it's going this way. Sorry. Yes, thank you. Good job. Yes. Yeah, my bad. Well, whatever. It's not 0. In this case, it's negative 1 over negative 1, which is positive 1. Yeah. Yeah, you're right. Yeah, good call. It is the third quadrant. Yeah, whoopsies. We all make mistakes sometimes. It's totally okay. Okay. Cool. I mean, the real way to do this is to, like, know what the graph of tangent of x looks like. You should know these. Graph of tangent of x. Which is this. And then because you should know what the transformations are. So this put a negative out front, so that flips it. Oh wait, that's not the right thing, sorry. There you go. So that flips it over the y-axis. And that's why instead of doing this, it ends up doing this. And then the 3 on the inside is going to decrease the period by a factor of 3 because it's greater than 1. So instead of the period here being pi, it needs to be pi divided by 3, which it is. It would just ask for the equation. Okay. Well then, yes, given the equation, you need to identify first, right? If it's doing this, then it has to be tangent or cotangent, okay? If it's going from up to down, that's cotangent. Sorry, that's negative tangent. And then if it's going from down to up, then it's positive tangent. Cotangent looks different, right? Where is cotangent? Yeah, cotangent looks like this. Oh, I guess you could write this as cotangent, though, couldn't you? Yeah, because cotangent and tangent are the same. They're just off by a phase. Yeah. Yeah, right? Okay. So this actually could have looked like cotangent, but it didn't have the right phase difference. So, yeah, it would need to come over by pi over 2, right? This form they have here, they have it going to the right by pi over 4. I need this to come over by pi over 2. So if you wanted to fix this one, right, this would just need to be pi over 2. And then you'd have the correct shift. Yeah, you could also write it as sine and cosine. Yeah, you could. I have a whole video on doing this for sine and cosine. I don't know if I did one for tangent yet. Let me see. Here. It'll just help you out. Where's my one where I did? Here, easy way to graph sinusoids. Yeah, here you go. I'm going to dump this video for you. Oh, you watched my sinusoid video? Okay, good. Yes. Good. Okay. Well then, yeah. It's a similar technique for tangent. Except that, so, here the quarter points are between 0 and 2 pi. Good, yeah, that's a good method. Okay, I'm glad that helps you out. Yeah, awesome. For those that don't know, here in the chat, that's my way to, this is my way that I graph sinusoidals. But tangent is periodic every pi. So, all you need to do is figure out where your answer is equal to 0, where it's equal to pi. Or where the argument is equal to 0 and where it's equal to pi, okay? And then you just need to figure out the halfway point, which is pi over 2. That's it. Yeah. It's the same thing for cotangent. I believe it's the same thing for secant. Is secant periodic every pi? No. Secant is... Okay, no, it's not. Yeah, secant's every 2 pi. Yeah, secant... Yeah, you're right. The cool way they graph secant... I like this. This is actually the cool way to do it. Is they graph it as whatever the reciprocal function is. So if you're trying to graph secant, they say, okay, do it for cosine first. And then, you know it's 1 divided by that. So anytime this thing gets close... Anytime... Let's say, for instance, you were having to graph secant of something. You could just grab cosine of it. And anytime cosine gets close to being 0, you know that you're doing 1 over cosine, which is equal to secant. Exactly. And so 1 divided by 0, that's what causes this to blow up. And then you know every time the cosine is negative, and it's reaching its maximum negative number, then that must be where like it hits like here. Yeah, you just do this. This is pretty cool. I just find the vertical asymptotes. Yeah, you can do that too. But your teacher might be asking you about this, by the way. They might ask you what this is. So it's kind of handy to have that number, I guess. Yeah. Okay. That's a good question. Cosmic, do you need any help for your physics test coming up? I'll help you out, dog. But good job, okay. Let me know if you have any other questions about that. That's a good question. I like that one. How long have you been streaming for? Hour 30? Yeah, you can ask whatever you want. Yeah, dump them. Dump them. Free homework help. That's what I say. Anyone else? Yeah, if you're in the stream and you need help with a quiz coming up or you got an assignment due, join our Discord. It's right there. And then you can post screenshots in the help screenshots channel. So this is an example of this channel we have that people are posting their stuff. Could you show the triangle inequality doesn't work for hyperbolic 3-dimensional geometry? Jeff, bro, I can't wait for you to stream. Jeff. When are you starting your stream, Jeff? I'm gonna come by your stream and ask so many great questions, Jeff. Never. No, we need to get Jeff streaming. I've made too many enemies. We'll just change your name. It's okay. Okay. Okay, he's gonna post another question. While I wait for him real quick, I think Taco Cat had some circuits questions they needed help with. Fake education, aka Dr. Pyrite. Yeah, fake gold. That'd be kind of cool. So we can ask a question on the stream every day and get a bond coin every day for that? Yeah, that's how it works. I mean, you can get credit for one of your questions per day. Yeah, you can't ask like 5 questions and get 5 bond coins. But anytime you ask a question, you get a coin. Just try to ask me a question that like is related to what you're doing in class. Like, don't ask me like, is 2 + 2 = 5? Unless you're like, I don't know, Terrence Howard or something. I mean, I have questions. Let me see. This is Taco Cat's question. He's doing circuits already, and I think he's like only in 9th grade or something. All right, equal posted yours. All right, let me do one of Taco's, and then I'll do yours equal. All right. So it says 3-cell battery, 3 lights, and an ammeter that measures current through the lights. Okay, so this is a cell. Cell means like, I don't know, like wafers, like batteries, I guess. So 3-cell means it must be this. So 3-cell battery. So that's got to be like this. There you go. That's a 3-cell battery. And then there's going to be 3 lights. What do they do for lights? Oh, they do this. So they go. So we go 1, 2. Oh, we can put another one here. 3. And then an ammeter. What do they use for an ammeter? Oh, they just put an A. Okay, that's cool. So then we just put an A right through here. And then goes into here. Yeah, the important thing in circuits is that if you're trying to measure the current in a circuit, you need to put it in series, which means you need to put it in line with everything else. If you wanted to measure the voltage, you actually like go in parallel with it. That's what you do. You do this. You hit like one end and you hit the other end. And that's how you measure voltage across something. Yeah, it's got to be in parallel. Okay, let me see equals. Oh, interesting, guys. Here's what Salah says. Salah says, I think it's true, but if I answer it like that, the professor will kill me. You got to write him a whole page of proofs. Oh, okay. Maybe just show what the limits things are. At n equals, or was it? Yeah, so I think for those we did x at 0, positive infinity, negative infinity, and then for set B can show yeah. This phrase is ambiguous. Yeah, I agree. Like, what's a whole page of proofs? What is a whole page of proofs? Wow, okay. It's a tricky one. He gave us a tricky one here, okay. Okay. Graph f of x is equal to 4 cosecant. Is that cosecant of absolute value of 2x? Is that true? Plus 2 on the interval of negative 2 pi to pi? Oh, wow, okay. Alright, fine. Okay. So I'm gonna do this. And plus 2, right? This is a vertical shift. So I'm gonna put a vertical shift up at 2. Just to make myself happy. We're gonna do this. Yeah. Vertical shift up at 2. And then I'm gonna look at what happens to this when it is 0 and well, let's see. Cosecant is that's 1 over sine. Okay, so I need to check when this is 0 and pi. Or all so the asymptotes, right, are going to occur anytime we take the cosecant of 0, pi, 2 pi, right? Should have used inter-rater intervalability tests. Okay, yeah. They're going off. That's nuts. 10 out of 10, 4 out of 10. Wow. Okay. Okay. Let's see. So my asymptotes, right, are anytime this is equal to n pi, basically, right? So 2x is equal to n pi. So I say that x is equal to n pi over 2. So I'm going to start drawing those as things. So let's say this is like pi over 2, pi, 3 pi over 2, 2 pi. I'm going to say this is negative pi over 2, negative pi, negative 3 pi over 2, and then let's put another one here. Say negative 2 pi. Can I make this line longer, please? Yeah, there we go. Okay. So those are the asymptotes, right? So let me make some smaller lines with those. Those help me out. Oh. This one's going to look weird, actually, because that absolute value is going to mess some shit up, for sure. Okay. And then I know that whatever the maxi mini thing or whatever, right, that has to happen in between all these points. So that's going to end up happening at, like, 3 pi. So I'm going to see if there's, like, a pattern first. Okay? So I know that something has to happen at 0. So if I take, oh, this is also an asymptote, sorry. Not 0. This is also an asymptote. Okay, cool. All right. So we have to look in between. So in between 0 and pi over 2, like smack dab in the middle, that's going to be pi over 4, right? So if I take 4 times 1 over the sine of pi over 2, and I do plus 2. Oh, I see. And then the cool thing about the absolute value is, like, whatever the values are here, they're going to mirror on the other side. Right? So whatever I get for pi over 2, I will get for the same for negative pi over 2. And whatever I get for pi, I'll get for negative pi. Because this will always force it to be just the mirror image x value. Okay. That's cool. Pi over 4 times 2 is pi over 2. Sine of pi over 2 is 1. So we get 4 times 1, which is 4, plus 2, which is equal to 6. Oh, wait, no, sorry. Yeah. No, that's actually okay. Wait. Yeah. Yeah. 6. Okay. So now we gotta go up. Oop. Okay. So I know that this... And then let me make my graph in a different color. Make it in, like, red. Okay. So that's this. So I know that has to do like this. And then I'm guessing... So the other one, right, is flipped. Because then if we go to 3 pi over 4 times... sorry. Yeah, if I go to 3 pi over 4 times 2, that's 3 pi over 2. So 4 sine 3 pi over 2. This ends up being negative 1, so I get negative 4 plus 2, which is going to equal to negative 2. So then 1, 2. And so this one is going to be here. Okay? And then you just do the same thing, because this repeats. Right? There you go. And then the cool thing is, because of, is it possible just to graph it as sine, and then cosecant, and then do absolute value to it? Yeah. Yeah, you could. Because this is going to be the same thing over here, right? So this is also going to do this. Yeah. If you wanted to graph it as sine, yeah. Because sine would usually look, you could do that as well. Because sine would usually look like this, right? Like that. Or whatever. Sorry, look like this. And then, yeah, the issue is that usually sine would go down here, but now it's absolute valued. So now it's this. You're not taking the absolute value of sine, though, by the way. Sine is still going to be negative. Yeah. The absolute value hits the x values. It doesn't hit the whole cosecant. So that's the important thing here. So sine of absolute value x is not the same thing as the absolute value of sine of x. This forces it to basically do this. This forces it to just reflect around the y-axis. You can graph this actually here. I can show you actually on Desmos. It's actually kind of cool. So that, yeah, they introduced this as a new thing. So if I say sine of absolute value of x versus the sine of x. Yeah. So they're different, right? Stalactites and stalagmites. Wait, don't the stalactites come up to +1? What is that? Sorry, what are you guys talking about? Yeah, equal. Does that make sense, by the way? The difference? Because look here. This is the red graph. You see how there's this weird, like, almost bow thing that happens at the middle? And then this is... This is... Oh, sorry. I have to put the absolute value of x. Sorry. This is what I wanted to show. This would be the absolute value of x. This would be the blue one. So this is just, like, bumps. Yeah, you can. Yeah, show me the harder one. Show me the harder one. Are you talking about this, Jeff? Oh, the pointy up thing should go to +1? Do they? Oh, no, they should go up to 2. No, sorry, I put them at -2. I fucked up. I make mistakes. Sorry. Yeah, it's 4 minus 1 plus 2. So, yes, very good astute point here. Wait. No, -4 plus 2 is -2. No. What's wrong? Wait. -4 plus 2 is -2. Is that not right? Oh, yeah, Jeff. Yeah, you're having me doubt myself, dude. It's okay. Yeah. Okay, post a harder one. Let me help out Taco Cat with his real quick. 2-cell battery. This is a cell. This is a cell. Ammeter always goes in series. A light. And then a voltmeter across the battery. Aha. This is where you gotta be sneaky. And you gotta do this. You gotta put a voltmeter like this. Voltmeters always have to go in parallel. Parallel means like this. This is like parallel. This is like two things in parallel. That's what we call parallel. And then this is what we call things in series. Yeah. Posted. Cool. All right, let's see it. Why does your teacher like absolute value so much, dude? What? No. All right. All right. No, not that one. I prefer things in perpendicular. Here comes the party pen. Okay. I prefer things perpendicular. Okay. This is a pain in the ass. Fuck. Alright. Alright, because we got absolute value, but it's also shifted. Okay, so this is symmetric about this. Right? Is that how it works? Wait, do I gotta pull a 3 out of this? Yes. Obi says pull the 3 out. Okay, fine. So 4 sine. And then he's saying this. He's saying 3 theta plus 2 pi over 6. The reason for this is because this is this is like a dilation factor. This is what is stretching it and compressing it. You always want things to be like, so you probably remember this from parabolas. Do you remember ax minus h squared plus b? Right? It's nice to have like the dilation before the thing happens or something. Yeah, 9. Everyone loves the 9s. Okay, fine. I screwed this up. My bad. Yeah. Okay. All right. Everyone's like 9. It's 9. 9. Everyone's yelling at me no in German. Yeah, sorry, my bad. Yes. Okay. Yeah. Here's the reason why they're doing this, is because now I can see that this is just going to be a horizontal compression of 3 with a horizontal shift of 2 pi over 9. Okay? Because if I want to graph this, right? Yeah, specifically to the left. Very good, Obi. Yeah. So this is up. This is a vertical shift. Vertical shift of 1. And then this is a vertical stretch of 4. Yeah, compression of 3, sorry, is like, it's like 1/3. It's like, compression is like it's like dividing by the number instead of multiplying. If that helps you out. So this I know is going to have a midline at 1. And then this 4 means, so this whole thing here, okay, is gonna oscillate between -1 and +1. So 4 times that is gonna go by +4 and -4. So that means my maximum top end is gonna be 5. Okay. And then my maximum bottom end is going to be -3. 1, 2, so -1, 2, -3. Okay, cool. I kind of like to draw these sometimes as well. And then yes, this function is going to start, right, with a shift to the left of 2 pi over 9. And you see how they're saying going from 8 pi over 9 to 4 pi over 9? So I think pi over 9 is my my scale that I want to use for things. Right? So let's do that. Let's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And I'm going to just say this is negative. Sorry, this is positive 4 pi over 9. And then this is negative 4 pi over 9. Or, I don't know. You could write all the things here. Just say, like, you know, horizontal scale is pi over 9s. All right. So, remember that thing's right. If it's like x minus h, right? This moves it to the right. So if it's x minus h, that moves it to the left. Fermion fusion, what's up, dude? I like fusion. It's kind of it was my focus in grad school. That's fun. So this is a minus 2 pi over 9. So it's going to go to the left by 2. Okay? So it's got to start here. And more off, this is sine, right? So sine always starts at 0. And so this is going to end up being here. Because this whole thing is going to be 0. That goes away. And then you just have a 1 shift up. Okay? Now, yeah, this is where like the bow type thing happens. Remember when we were showing this, right? For what was it? No. So watch, sine of absolute value of x. It does this weird thing where it mirrors itself, right? And if you wanted to move this over, so let's say in our case, right, we had like +2. Do you see how like where this bow happens, where it mirrors, shifts over to the left, right? So this location right here, this is where the whatever this will happen. Because usually sine would want to look something like this, right? We'd want to keep doing it like this. But this absolute value causes this like ripple to happen, where then it does this. Okay, so I know that that's there. So then what I want to do is I want to just set this equal to 0 and set it equal to 2. Well, we already set it equal to 0. That was at negative 2 pi over 9. So I can set it at to 2 pi, right? So I can say 3, let's just say theta plus 2 pi over 9 is equal to 2 pi. And that'll tell me where like one cycle goes, right? So that's theta plus 2 pi over 9 is equal to 2 pi over 3. That becomes 6 pi over 9. So theta is equal to 4 pi over 9. Oh, so that's cool. So that's a complete cycle. All right? So we know that this thing is basically going to have to do this. And then it's just about finding the points in between, right? So we know halfway in between it has to hit 0. So that's like 1, 2, 1, 2, right? So that's here. And then halfway between those 2 points... wait, did we do that right? Yeah. And halfway between those 2 points, it has to also do 0. Well, no, it goes up and then it goes down. Oh, so that's gross. Yeah, because we have 4 pi over 9. So we have 6 pi over 9. And then we have to divide that by 4. So it's 6 pi over 36. So it's 3 pi over 18. That's my markers. Oh, man. Yeah, okay. So yeah, the tricky thing here is finding the midpoint between here and here. It's technically like right, it's like right here. And then that's going to be all the way up here at the top end. So that's over here. This is down here. So then your graph ends up looking like... let's not use pink. Let's use blue. Let's use this. Okay? And then on the left side, same thing. So it has to go over 1, 2, 3, 4, 5, 6. It's got to go over 6. So 1, 2, 3, 4, 5, 6. Here's the other one. Here's the half. And then here's, I guess, the quarter. And here's the other quarter. But instead of doing this, it's gonna mirror this around this point. It's mirroring. So it's gonna go up and then down. And then hit the bottom and then go up like that. Yeah. That's what that's gonna look like. I'm pretty sure. Does that make sense, L? Like how that works? This is, yeah, I think the tricky thing is I guess visualizing all this, but knowing that this right here, this is where things mirror each other. You want to find that mirror point, which is always where the absolute value is equal to 0. The answer key, the bow part happens at negative 4 pi over 9. Does it? Did I do something wrong, guys? No, it should be below the midline. The absolute value is on the x coordinate. Oh. Oh, wait a minute. Wait a minute. Oh, because, yeah, okay. Because sine is always positive. Oh. No, wait. Let me switch. Let me switch what I'm doing. Yeah. Yeah. Yeah, no, I see where the issue is. Wait. No. No, we're okay. No, we can have negative numbers. Yeah, sorry, Obi. Yeah, you're right. We can have negative numbers. I got worried there because I was like, wait. We're only taking the sign of positive numbers. Yeah, there's a Discord. Yeah, okay. Yes, send me what your teacher did. I don't think your teacher's right. It's okay, Obi. It's 2 a.m. here. Yeah, bless your soul, dude. Thank you for staying up so late, man. You're awesome, dude. Yeah, if I do this, I think I do like time UK. Yes, it's 1:58 in the morning for our friends across the pond. No, I almost thought the same thing though, Obi, because I was thinking of if you have a coordinate axis, right? And then this is sine, then yeah, you should technically, if you're only picking out positive values, but the problem is like, this is also positive values of theta. I almost had the same thought as well. You're good. Yeah, let me see it. All right, I'm posting it. Yeah, no, because they're doing over 18. Do you see here? Do you see how they say negative 4 pi over 18? That's negative 2 pi over 9. Oh, no, you're okay. You're not slow, dude. I mean, honestly, your teacher did it probably better. Because do you see how I kind of had to guess, like, in between these two values? Really, my scale should have been pi over 18s. But I really just wanted the zeros. Because I know halfway in between the zeros is going to do the thing. What's up, Waffle? Good to see you, bro. Long time no see, Waffle Walrus. Yeah. No, it's the same. Your teacher, they were just poopy marker 2ph. Yeah. Yeah, also, like, that's hard to read, dude. But yeah, I get it. It's an 18. Yeah. They just did it by 18s. We did it by pi over 9s. Anyways. Yeah. Does that help you out? Yeah? Good question. Okay. I gotta go pretty soon here. Let me draw these real quick for... Yeah, you're very welcome, dude. Let me draw this real quick for Taco Cat. Two lights in parallel. Oop. Oh. I don't like drawing these lights. And a voltmeter across the battery. Yes. Voltmeters always have to be in parallel, Taco. Always gotta be in parallel. Ammeters go in line with things. Voltmeters go parallel to them. It's gonna be the same thing here. 3-celled battery. 3 lights in parallel, so that's this. 2, 3. And then same thing. If you want to measure the current, you got to put the ammeter here. It's kind of cool that he's learning these. Yeah, Fermion Fusion. Did you have a question you want to submit for us to go through? I gotta go pretty soon, but if you submit one real quick on the screenshots, I'll do it. Otherwise, yeah, more than welcome just to join and chill out and see stuff we do. This is a student Taco Cat needed help with his circuit stuff. So this was a 2-cell battery. That's 2 cells. Ammeter goes in line. 2 lights. Well, they don't say whether the lights are in series or parallel. So it's actually kind of a shitty question. Got my 7K steps. I'm back. Surprised you're still streaming. I do have to go. I do have to go pretty soon here. I'm just showing this for Taco Cat real quick. He can't make the stream because he's, I think, at volleyball practice. So I'm showing him on the stream here, and then I'll record it for him. Yeah. Yeah, see, they said they're in series. So this is an ammeter, 2 lights in parallel, and 2 voltmeters across rods. It's the same thing, dude. What? Can I just copy this? Yes, I can. And then get rid of this. Get rid of this. Get rid of this. Get rid of this. And then this needs to be a voltmeter. And then this needs to be a voltmeter. And then the switch and the bulbs are harder, but it's okay. We'll help them out with that later. Okay, this goes to Taco. Just here to watch. Oh, all good for you, Fermion. Yeah. So yeah, we're a nonprofit. We help students with like math and science stuff, homework, you know, preparing for tests, quizzes, and stuff. We have a lot of other really cool math. Are you into math at all? I have a PhD in physics, but I teach a lot of math. But we also have a lot of other stuff. There they are. So yeah, make sure to go give all those guys a follow. They taught me real analysis today. Thank you. That was really fun, actually. Okay. Cool. All right. Okay. It's been 2 hours, 6 o'clock. I gotta run. But let's close out the stream and go raid someone awesome. Okay, cool. Thank you, everyone, for coming to office hours today. Had a great time going through all the math and science questions about stuff. Yes, I can do your waffle. Let me do you real quick. One sec. I'll do your question real quick. No, go away. Goodbye, credits. Okay. Really quick help with the order of operations for function transformations, dilations. I need the list because my teacher didn't teach it. Yeah, all good. I'll do it for you. No, I'll get you waffle. I'll get you right now, waffle. He's finally done with his exam. Yeah, okay. Here you go. Yeah, order of operations. It's like horizontal. I always like to think of like going outwards is what it is. So here's what you have, right? You have x plus a. You have f of like 3x. Then you have f of x. I think it's this. Well, here, let me put them this way. Let me make them as x. And then it's a f of x. And then it's f of... what is that? It's going to be f of x plus a. Yeah, one sec. Yeah. So it's horizontal shifts first. Then horizontal dilations, I guess is what you call them. And then it's vertical dilations. And then it's vertical shifts. The way I always like to think about it is like, let's say for instance I had f of x was equal to, I don't know, like 3x minus 4 squared 5 plus 6. Reflections happen in the dilations. So these are also reflections. Yeah, those are the multipliers. So look at this variable, right? You just think order of operations. So the first thing that happens is some sort of horizontal shift. Then you get some sort of horizontal dilation, which can be a reflection. And then you basically have the function, right? You have squared. then this is the next thing to hit. That's the vertical reflection or vertical dilation, whatever. And then you have the vertical shift finally. That's how I do it when I graph. I look at it this way. We got both kinds, country and western. What's country and western? What's that? Anyways, does that help you out, Waffle? With like order of operations for stuff? I just think about the equation of a parabola. And I think of how it's structured. And this was also Blues Brothers. Oh man, I need to watch more of that. I know what you're talking about. That's also why the boys made me do this. When we had something like this, they saw that this was already kind of like a, you know, like a 3x minus, I don't know, 5 type thing. And they're like, pull out the multiplier. So if you pull out the multiplier and leave it so that it's just the variable stripped, like the variable's naked here, just with some sort of horizontal shift, then you know to do the horizontal shift first and then do any stretching and stuff you need to do. Yeah. Okay, cool. All right, with that, I'm actually going to end the stream. All right, cool. All right, thank you everyone for coming out. Next stream is going to be tomorrow. That's going to be at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. Come on through, get help with your homework. You got tests coming up. We'll get you ready for them. Big special thanks to all the awesome math chads and streamers that help out with my stream. Appreciate you guys teaching me things that I don't know. I learned stuff today. Yeah, it was super cool. All right, let's go raid someone. Is Penn Center doing his class today? Or was that yesterday? I gotta remember who it is. But yeah, also, if you just found us on Twitch, join our Discord. It's the easiest way to figure out the next time we're doing another stream. Our schedule's pretty regular. Oh, Nitro. Yeah. Oh, yeah, if you have Nitro, that'd be awesome. Yeah, because I think ours is about to run out or something. Zach should be on soon. Zach, are you on now? Can I raid you? Oh, in about 20 minutes? Oh. Who else is on? Who else is on that will raid you next? Damn it. Suburban Lion. High potential. I don't see anybody. Keep going for 20 minutes. I have to go. I have to teach another student, unfortunately. Yeah. Otherwise, I would stick around. I would stick around and stream. But I have to go to the student. Jeff will go live to raid Zach. Yeah, Jeff. Jeff, you want to come live? Yeah, Jeff, you want to go live for us real quick? Come on, Jeff. Yeah, Jeff. Now's your time to shine, dude. Show me your channel, dude. I want to raid you. I want to raid. He says no. Sorry, I have to ... Let me see who else is in. So yeah, was it paleontologizing doing something? Dinosaur Q&A. Has this guy been up for 5 hours? One second. Let me see. How long has he been going on for? Oh, he's offline, so he's not even streaming right now. Ugh. Yeah, where's your stream, Jeff? Jeff, where's the stream? One sec. Because we've got so many fun people here. This person's doing science. No, who do I follow? Starting soon. Jinxie. Science doesn't start for another 10 minutes, I don't think. Astronomy show is cool. This go? Okay, all right, cool. Just go say hi to him. Sorry, I would stick around to raid you, Zach. Yeah, sorry, I gotta go teach a student. But all right, go say hi to astronomy for us. Also, yeah, make sure to go. Actually, yeah, go follow Zach for his class coming up. We're gonna learn about infinitum and infinitum. Yeah, there you go. Infinitum and what was it? Extremum, infinitum and something. Supremum. Yes, I love that. Okay, cool. Supremum. Yes. All right. Have a wonderful rest of your Tuesday. I will see you guys on Wednesday. Peace out.